In this video we shall look at continuing the introduction of inheritance into the network project, which we started in the previous chapter. The aspects of inheritance we shall be particularly interested in are method overriding and method polymorphism. In the previous chapter we saw how to eliminate a large amount of the code duplication that was present in version 1 of the network project. Duplicate code was moved to a general post superclass, and the original more specific types of post class became subclasses, inheriting their shared features from the superclass. This allows us to create additional types of post very easily, because they too can inherit existing functionality without introducing further duplication. However, the refactoring process has actually introduced a problem that needs to be addressed, and the purpose of this video is to demonstrate some steps towards a solution. We start looking at the problem using a copy of version 1 of the network project. This has had a test class added. The test class makes it a lot easier to set up a standard set of objects to investigate the program's behavior, but this is still the original version of network before inheritance was introduced. The object bench contains a newsfeed object, a message post object, and a photo post object. If we show the current state of the newsfeed, we can see that it already contains the message post and photo post. There is a comment on each, and one person has liked the message post. If we now look at version 2 of the project, the one with inheritance added, and show the newsfeed that is in exactly the same state as that in version 1, we see that the output of the two feeds is different. There is less information in the feed from version 2. In the version with inheritance, the only information in the feed is that stored in the fields of the post superclass. Neither the message text from the message post nor the file name and caption from the photo post appear in the terminal. This is clearly a problem. While we might have improved the quality of the code, we've reduced the functionality of the project, which makes the improved quality of questionable value. The reason for the problem seems obvious. From the class diagram in version 2, we can see that the newsfeed class now knows nothing about either the message post or photo post classes. It only knows about the post class. This effect of the introduction of inheritance is confirmed if we look at the show method of the newsfeed class. There we can see that each item in the newsfeed's collection of posts is treated as a post object rather than as a message post or photo post object. Indeed, it was actually seen as being a benefit of inheritance that the feed no longer needed to maintain a separate list of every specific type of post. However, the consequence seems to be that we've lost some vital information. A post object only has access to the data stored in its fields, so that's the only data it can print from its display method. It would appear that the only way around this problem is to move the display method out of post and back to message post and photo post, where full information is available. This version is an attempt to do exactly that. We've moved the display method out of post and put it back in the two subclasses so that they can add in their distinctive pieces of data. In the process, we had to add additional accessor methods to the superclass so that the subclasses could retrieve the values in the superclass fields. These accessors are called at the start of the display methods. As can be seen, message post compiles, so it looks like this might work. But even with this strategy, we have to recognize that we've reintroduced code duplication. However, there's an even more fundamental problem. If we try to compile newsfeed, then it fails. The error is cannot find symbol method display. On one level, this seems like a reasonable error. After all, we've just removed display from post to put it in message post and photo post. On another level, however, it's unreasonable. The post objects that the newsfeed is dealing with are actually all either message post or photo post objects, so we know that they do actually have a display method. Why then won't the compiler accept this? The issue is that the compiler looks at the declared type of a variable when it checks the validity of a method call. The declared type is also known as the static type. If the class of the declared type does not have a method of the given name, then the compiler rejects the call without checking the subclasses. Fundamentally, this is because the compiler actually cannot know for sure that the object being referred to here does in fact have a method of that name. For instance, we could easily have created a new subclass of post and forgotten to include a display method. In that case, a call to display would be a runtime error. So we seem to be in a cleft stick. On the one hand, the post class must have a display method that cannot do the job we want, and on the other hand, only a display method in the subclass has access to the full set of information we want to print. However, there is a way out of this dilemma, and this is the main point of this video. Let's look at a third version of the network project. In this version, we've abandoned our attempt to move display from post to the subclasses. The post class again contains the inadequate version we've seen before in order to satisfy the compiler. And the newsfeed class is exactly the same as before. It still only knows about the post class. What is different about this version is that we do also have a display method in the two subclasses. This time, though, these methods only display the fields stored in the subclass part of the object. They don't attempt to output details from the superclass part 2. Using the same test state of the newsfeed as we saw before, let's see what happens in this version. What we see here is completely different from version 2. In version 2, we only saw the information in the common fields. In version 3, we only see the information in the subclass fields. Yet we haven't done anything different in the newsfeed class. It's still calling the display method on a variable whose static type is post. What is happening here is one of the distinctive features of inheritance in object-oriented programming. The effect is the result of method polymorphism. In other words, it's because there are alternative versions of the same method in superclass and subclass. In the previous chapter, we explored polymorphism in the context of types, and saw that the requirement for an object of type post could be satisfied equally by an object of type message post or an object of type photo post. A polymorphic post variable might refer to an object of the message post type at one point and to an object of the photo post type at another time. In other words, while the static type of the variable will always be post, its dynamic type can vary between the different subclasses of post, depending upon which type of object it happens to be referring to at any one time. That's exactly what's going on in the for each loop of newsfeed's show method. What we're seeing here is that the dynamic type comes into play when a method is called on an object. It's the dynamic type that takes precedence over the static type of the variable for method calls. We say that the version of the method in the subclass overrides the version in the superclass. So although it would appear that the call here in newsfeed is to the display method of the post class, because the static type of the variable is post, it's actually to a version of display that's defined in one of the subclasses. We can easily see this in action via the debugger. We set a breakpoint at the call to display in newsfeed, and then call its show method. When we step into, we find ourselves in the display method of message post. If we complete that, and then step into the next call to display, this time we're in the display method of photo post. This reflects the fact that there is one message post object and one photo post object stored in the posts list. Method polymorphism turns out to be a very powerful mechanism in object-oriented languages. However, notice that, interesting as this is, we still have not got back to the style of listing we had in version 1 of the network project. If anything, version 3 displays even less than version 2. At this point, you might be tempted to see in method polymorphism a way to get the full output via version 2a that we looked at earlier. Recall that this version would have printed all the information we wanted, but it was hindered by there being no display method in the post class. Since the display method in post doesn't appear to have any use, it is overridden by the versions in the subclasses. Why don't we just put a dummy version in the superclass to keep the compiler happy? As anticipated, we finally have the output we want. However, this is not really the best way to solve the problem. Recall our earlier criticisms of this version. Duplication has returned to the subclasses, and we could easily forget to define a display method in future subclasses. In the latter case, the inherited display method would not have been overridden, and we would get no output for objects of such classes. There is actually a better solution that involves a relatively small change to version 3 of the project, and yet carries with it none of the disadvantages we've discussed here. That is covered in the chapter, and we won't deal with it now. In summary, we've seen that the compiler checks method calls on a variable against the declared type of the variable. The declared type is also called the static type. We've also seen that subclasses may override a method defined in their superclass. At runtime, it's the dynamic type that's used to determine which version of a method is called, with the overriding version being preferred.